All right, here we go again, page 5. You guys are almost done. Keep working. By the way, if you ever finish the packet and you're like, I still don't feel confident on the test, you should really go back and practice the problems again. Redo the problems again that you had trouble with. That's the best way to practice math at this point, especially the kind of math that you guys are working out. Anyways, so here we go. The distance between these 2 points. Okay, so the distance is, formula is this: x2 minus x1 squared plus y2 minus y1. You know, it doesn't matter which one's x2 or x1 or y2 and y1. That's just the way I like to write it. But it does matter that it's subtraction and plus there. Okay, so let's find the distance. Square root. Let's do the x's. 3 minus 6 squared plus -1 minus 5 squared, which is going to be square root of -3 squared plus -6 squared, which is square root of 9 plus 36. And it's going to be the square root of 45, which is about 6.71 units. X1, distance between those 2 points. Distance equals the square root of these things. There's minuses in there, and there's pluses in there. That's kind of how I like to memorize the formulas anyway. So 7 minus 0, 13 minus 6. That turns out to be the square root of 49 plus 49, which is the square root of 98, which is about 9.9 units. Distance between those points, again, boom, 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 boom. You got to remember this formula here. So -7, -2 there, and 0 and 12. It's going to be the square root of 25 plus 144, which is square root of 169, which is 13 units. All right, let's keep going. All right, for my folks, we're trying to find if this is isosceles. So let's turn around and see if that's the case. All right, guys, let's take a look at. We're going to change this word right here to a right triangle. That was just for fun. Anyway, so let's see. Essentially, what we have to do is we have to go out and we have to find the distance between all three of these points. And if you don't know what to do, 1, 2, 3, 4, 5, 6, 7, you can plot it and kind of take a look at what you're doing. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 0. X, W. So we need to find three distances. We need to find WX. Okay, we need to find WB, and we need to find XB. And the reason why we need to find that is if it's a right triangle, we have to check to see if those three sides, follow with the Pythagorean theorem. So we go ahead and we calculate what the distances are. So WX is going to be -3 minus 7 squared, and then -4 minus 0 squared, and that's going to equal square root of 58. We're going to leave it that because we're going to throw in the Pythagorean theorem in a second. So, oops, sorry, I did that math wrong real fast, wrong one. So that's going to be, WX is going to be the square root of 116. Okay, so now let's look at WV. WV, right, we can take -3 minus 4 all squared plus -4 minus -7 all squared, and that's going to wind up, when we calculate that, we get square root 58. We're going to leave it like that, and X or V, XV or VX, we're going to go ahead and calculate it. So XV, 7 minus 4 squared plus 0 minus -7 squared, which is going to be the square root of 58 again. So let's see if it's a right triangle. So, okay, we got to find the longest side. So in the picture, it was WX, and mathematically with the square roots, it was WX. So we're going to take that, and we're going to say, is that squared? Is that equal to these two guys? Squared, that's an 8, by the way. Terrible looking 8. Anyway, squared, 58 squared. Is that equal? Well, it's 58 plus 58 equals 116. Is that true? Yes, that's true. Yes. So it is a right triangle. Okay, let's crank out the last one. Last one, guys. Good work. Keep progressing to the end, and persevering, and working through the problems again if you don't get it. You got some time. Hopefully you worked on this a little bit beforehand. when I submit it, put it online, and we can go from there. 1, 2, 3, and then put 1, 2, 3, 4. Let's see if this guy, this sucker, is a right triangle. Is it a right triangle? Okay, so we're going to find three distances. We're going to find AC, we're going to find CB, and we're going to find AB. Okay, and we're actually going to do this the same way up above. Okay, I'm going to cut to the chase and just make it a little shorter here, but that's going to give you a 1/16 when you find the distance between points A and point B. And then CB, you're going to find that the distance is square root 20, and then AC, you're going to find that the distance again is square root 20. So let's see if it's right triangle. We got to find the largest side. Well, the two square root 20 is the largest side of these three numbers, but there's two of them that are square root 20. So, you know, by default, if it's a right triangle and the hypotenuse has to be the largest side, and there's another side that's equally as big as square root 20, it can't be a right triangle. But we can turn around and do it like this if we want, and just check the Pythagorean theorem if that holds true. So we're going to see, is that true? 36 equals 20. Well, we knew that that wasn't going to be the case, so no, it's not a right triangle. Anyways, hope you had a good job. Did a good job on that. If you need more help, email me and ask me some questions as we go through. But otherwise, peace and good luck. So peace.